Okay, since I'm not going to be here for lab tomorrow, I'm very quickly going to go over some of the most important parts of the experiment. My hope is that you will listen to this and be prepared for lab tomorrow with Dr. Spencer. So what our whole experiment is about is going to be Ohm's law and this formula. Okay, so we're going to have a known voltage, a known current, and then we can calculate resistance. So let me move us across to lab. So remember, we're going to be down in the physics lab, which is room 103. And this is going to be your setup tomorrow. You're going to have a voltmeter, an amp meter, 5 wires, a little bitty resistor, and then the power supply table. Okay, so everything's going to be hooked up when you come in, and then you're going to have an unknown. And that's for this group C, it'll be unknown, for group 3, it'll be unknown C. Okay, so what we are going to do, if we look at the procedure, is it says, number 1, set up an electric current. Well, that's already done. Okay, so you don't have to worry about that. You don't have to worry about the step 1, but what you do have to do is, first of all, you're going to calculate the resistance of your resistor that you have there. And you're going to do that with Appendix 1, which is the very last part of your report. Okay? So for example, if I have a red, brown, black, gold resistor, so you can see this one has opposite, it's yellow, violet, brown, and gold. You can calculate the resistance using this diagram. So my first color was red. A red corresponds to a 2, so you see I have that written down there. Brown corresponds to a 1, so I have 21 times what's called the multiplier, the third line, and for this case ours is black, which is 0. So that's times 10 to the 0, which is 1. And then gold tells us our error, which down here, our deviation, which is plus or minus 5%. And all of ours are gold. Okay, so what that comes out to be is 21 times 1 plus or minus the 5%. And so to figure out what the deviation is, you take 21, multiply it by 0.05. This is the decimal form of the 5%. And it gets you 1.05, meaning this resistor is 21 plus or minus 1.05 resistance, ohms. Okay? Now, to compare that to something else, you have red, brown, brown, meaning now I have 21, and my multiplier is 10 times 10 to the 1. And this makes it 21 times 10 instead of 1, giving me a number of 210 instead of 21, but I have error almost identical, except it's 10.5 instead of 1.05. Okay, so you're going to calculate the resistance of your resistor, and then ask Dr. Spencer, and he will confirm it before you start. Once you have your voltage or your resistance approved, then you will begin. The table will be turned on for y'all. And then what you're going to see is as you turn this knob, you should see an increase in both the voltmeter and the amp meter. Okay? And you're going to pick 6 different measurements. Now, note that this says 10. So when you look at the scale here, you're going to read the one that goes 0 through 10. If it was hooked to the 3, you read 0 through 3. If it was hooked to 15, you read it 0, 5, 10, 15. So it's like having 3 different rulers on the same meter. Okay, but most all of ours are hooked to 10, and this one's 50. Okay, so 10 and 50. So if I pick my first voltage reading as approximately 1, then I'm going to go over to the ammeter, and I'm going to say, okay, this is on the scale of 50, so 0 through 50 milliamps. This is approximately That's 5, so this is 2. Okay, so you go to your table and you write voltage was 1, current was 2. And then we pick another voltage. So I'm going to make it, how about 3? Okay, so now my voltage is 3. My amp meter is between 6 and 7, meaning I'd put about 6.5. So 3 and 6.5. And you do that for all 6. Okay, and then you don't do anything else in lab because of the amount of space we don't have in here. Then you're going to turn your table down and you're going to replace your resistor with this one. So I would recommend taking off one clamp, putting it on your resistor, the second one, putting it on the other one, third and fourth. That way you don't mix your wires up. And then you're going to write your unknown resistor number or letter, because I'm giving you all letters, and you're going to do 6 known voltages and take the current, and then I'm going to email you with number 7. But you'll do all the rest of it, the table or the graphing, on your own, and I will try to post more information about that later.